So this is first part of Newton's second law of motion. This is on chapter 5, force and acceleration. So basically, as you already are well aware, that all forces, especially net force, will cause an acceleration. And so the equation that we have grown to love is F net is equal to ma. And basically how you would read it is that when you take a net force and you apply it to an object with mass, then it will accelerate. And we have basically mentioned that in class already. So whenever a net force is no longer applied in a situation where there is no friction, that object will undergo constant motion, much like what the first law will state, where an object in motion will stay in motion. So if we are going to increase the acceleration or change or give an object an acceleration, then you would have to apply a greater net force. So apply a net force, the object will accelerate. So what we are able to say is that net force is basically directly proportional to acceleration. Look at the equation. F net is equal to ma. If I increase acceleration by 2 units, then the net force will also increase by a factor of 2 units. So it's directly proportional. So here's a kid, he's basically zooming along, applying a huge amount of net force, causing his tricycle to zoom forward. Now, mass is basically something that will resist acceleration. So if the same amount of force was used to accelerate two objects of different masses, the object with less mass will undergo a higher acceleration than the object with more mass, because we can say that acceleration is inversely proportional to mass. Basically what we're saying is if you have something really small and also not very massive versus something that has a lot of mass, if you use the same amount of force, say you use 10 newtons of force to accelerate both objects, one with less mass, one with more mass, the object with the lesser mass will accelerate at a higher rate. So here we have a dragster, a motorcycle, and we have another dragster. And so basically you got two vehicles. Of the two vehicles, it's pretty obvious that the motorcycle will have less mass. And because it has less mass, it's going to deliver the same amount, or it'll deliver much more acceleration than the two vehicles. As long as let's just say both vehicles will be able to exert more mass, the same amount of force, the one with the more mass will accelerate at a lower rate than the object with the lesser mass. So the question is, if both vehicles utilize the same net force, which will accelerate at a faster rate? So that's pretty self-evident at this point. So here's Newton's second law of motion. In the actuality, we have already determined the Newton's second law of motion. It's really F is equal to ma. But how Newton wrote it is that acceleration is equal to force divided by mass. That's how he wrote it. But we have grown to appreciate the fact that F is equal to ma. It's a little bit easier to remember. So if you have here a Ford Mustang Cobra Shelby, and you have a Dodge Charger, both have about the same mass. But the Ford Mustang Shelby has 540 horsepower, basically a lot more force, can deliver a lot more force, whereas the base model of the Charger will only have 190 horsepower. So between the two vehicles, what can you say about the acceleration of both vehicles? Okay, so that answer is I think should be pretty basic at this point. So essentially what Newton's second law of motion is able to do for us is it gives us a way to quantify force and acceleration. And what the word quantify means is very easily put, calculate for force. It doesn't define what a force is. It just gives us a way to calculate force. So here are some practice problems. A skater can accelerate at a rate of 1.5 meters per second squared. If her mass is 55 kilograms, how much force is exerted? So as you can tell, there is probably only one equation that you know of right now, which is F net is equal to ma. And over here, you can see that the acceleration is 1.5 meters per second squared. Her mass is 55 kilograms. Remember, mass is measured in kilograms. And we have acceleration. So we'll just need to calculate is the force. So we'll start with the equation F equals ma, and we will start plugging in the values of mass at 55 kilograms and acceleration at 1.5 meters per second squared. And so you'll multiply the two values and you get 82.5 newtons. Of course, we're going to be rounding for significant digits, so we're going to round it to two significant digits to 83 newtons. Number 2. If a car can accelerate at 2.0 meters per second squared, what acceleration can it attain if it is towing another car of equal mass? So the question you need to start asking yourself is, what is changed here? What's going on here? So basically, you're looking at this problem. A car can accelerate at 2.0 meters per second. That's basically what you're looking at. And so if you got a car of equal mass, that's towing another car of equal mass. Basically, you double the mass. So if you double the mass, you will be able to determine that acceleration will be halved, since it's inversely proportional. Okay. So far so good. Same force on twice the mass produces half the acceleration, or 1.0 meters per second squared. Inversely proportional. Double the mass, you will then take half off of the acceleration. Okay, more practice problems. Since Newton's second law is mostly on quantifying or calculating for forces, we'll be doing a lot of force calculations this chapter. What is the mass of an object if the force acting on it is 294 newtons, which accelerates the object at a rate of 10.0 meters per second squared? So here we have the mass is the question, and then we have the force, which is a given. Then we have the acceleration of the object, and so we're basically solving for mass. We're always going to start off with F equals ma. Solving for mass, we'll basically divide both sides by acceleration. So we're left with mass is equal to force divided by acceleration. Plugging in the numbers, force as 294 newtons as stated in the problem, divided by 10.0 meters per second squared as stated in the problem. We'll have 29.4 kilogram, 3 significant digits. We leave it at that, and we have completed our practice problem. If you have any questions, of course, remember to ask in class. We'll have some time tomorrow and the day after to answer and address your concerns. So we've talked about friction. Friction is a force. In fact, it is a force that affects motion. And so, of course, as you know, there is no real place where friction is completely ignorable, because no matter where you go, there will pretty much be friction. Because friction will always exist between surfaces of materials. And at the moment, there isn't any materials in existence that is so smooth that it is frictionless. And friction will always act in a direction that will oppose motion. So if the motion of the object is in a positive direction, friction will always be exerted in the negative direction. And the reason why friction exists is because it is caused by the imperfections in surfaces, the irregularities between the surfaces, so the bumps and crevices and the pits in surfaces that we don't see with our naked eye, but we're able to see under microscopes. And it is those irregularities that causes the friction. So you can imagine an object with more irregularities, more pits and crevices and things of that sort. It will be able to grip onto another surface more readily, therefore more friction. So the force of friction will depend on the materials in contact and how much the surfaces are pressed together. So at home you can try doing this little exercise. I'll describe it to you. If you put your two hands together and you just gently rub your hands back and forth, you would feel that there would be some resistance force, some frictional force. So what happens when you press your hands together harder and try moving your hands back and forth? Is it easier or harder? Do you experience more resistance? Well, the answer should come out as yeah, there should be a lot more resistance when you press your hands together, which means that when you are in a situation where you have an object that is heavier, therefore more weight, more force of gravity, rather the normal force pushing up on the mass of the body of the object, that force, that pressure, that weight is basically what determines how much, it's one of the two factors that determines how much the force of friction is basically equal to. So we also have fluid and air resistance, also different forms of friction. So now what we have here is a situation where friction is always going to be present, but an object can still move at a constant velocity, because even though friction is there, we will still be able to move at a constant velocity, as evident as driving on the freeway with cruise control. So in order for that to happen, what we'll have to do is we'll have to move the object at a constant velocity, because the force propelling the object must balance out the force of friction. So what the forward force, the propulsion force, must equal the resistance force, which is the friction force. So parallel force must equal to the frictional force in order for us to have a constant velocity, which means that we will have a net force of 0. So there are three kinds of friction. There is kinetic friction, friction that occurs when two objects are moving relative to each other and rub together. And then there is static friction, the force between two objects that are not moving relative to each other. And we have rolling friction, the frictional forces associated with the rotational motion of a disk or other circular objects along a surface, basically like a tire on the ground. Okay, we are mostly going to be working on kinetic friction and to some extent static friction, and almost to no extent rolling friction. It's a little harder to determine, so we're just going to stick with the kinetic and static friction. Now, more about kinetic friction is that it is dependent upon the contact surfaces between the objects. So the rougher the surfaces, the more friction that you're going to encounter. The weight of the object basically will create a pressure between the surfaces. And the equation is F of F, frictional force, is equal to mu k times F of n. The mu k value is basically the coefficient of kinetic friction. It is a constant. It is a number that we engineers have assigned to different contact surfaces. So if we have rubber on concrete, there's one different number. Is a different number. If we have ice and metal, that's a different surface. Teflon on metal is another kind of mu k. Now F of n is essentially the weight of the object. So the more weight, as you can see, is directly proportional to force of friction. The greater the mu k, the higher the frictional force. Okay. Are there any questions? If you do, write them down. We'll address it in the next coming school days. So here are some problem-solving strategies. We'll go over this. Basically, you will draw a free body diagram, and the vector arrows must be of the appropriate lengths, showing the proportions of the magnitude of the forces. And then you all should have the correct numbers of force vectors. Don't add additional force vectors if they don't belong. Identify all the variables by writing them down and encoding the values for each of the force vectors. Identify the forces in both x and the y directions. Set up the equation, which is F net is equal to the sum of all forces. And when F net does not equal to 0, it is equal to MA. See, the F net equation should be separated into the x and the y directions, meaning that there are two separate equations, one for the x and one for the y directions. Okay, so we'll solve the problem using the above equation and fill in the unknowns, so on and so forth. Okay, now with regards to the problems that we're going to have, you can see in the PowerPoint, we'll be working on those in class. So we'll stop here as part 1. And we'll continue to work on the friction force problems. Make sure you follow the link in the folder for the web assignment.